So hi everyone, welcome to Raaonline. This is Dr. Srivatsan, your faculty for biochemistry, and in today's session we will be seeing about translation part 1. So translation is a huge topic and I have just separated into various parts so that it will be easier for you to grab the concepts. Today's session we will be seeing about what are the requirements for translation. So we'll go into this session now. So you all know the central dogma of molecular bioenergy, in which DNA on replication will form another DNA, DNA on transcription will form RNA, and this RNA then can translate to form a protein. So this is just a change in the format. So you have a book in written format, the classic written format is there. You try to make a copy of that book, you try to change that format into a digital format. So this process is called as transcription. So that book has been transcribed into an entirely different format. From written format, it has been transcribed to entirely different printed format. Now that printed format, you want to distribute it all over the world so that it is in as a separate language, and you want to convert that into another language. For example, if that original copy is in some kind of a language, some kind of an Indian language, say for example Tamil means, you try to change that, you try to translate that into English so that it can be distributed all over the world. So this process is called as translation. So this is the central dogma of molecular biology, and in the earlier session I have explained in detail about various kinds of transcription changes which occurs in prokaryote as well as in eukaryotes. Now in today's session we will be seeing about translation. Okay, so what was the product of transcription, guys? The product of transcription, it indeed had an we have synthesized a new RNA. That RNA was a heteronuclear RNA initially because it was unedited RNA, and to this heteronuclear RNA it had undergone various kinds of post transcriptional modifications. So after post transcriptional modification, this has get converted into a mature RNA. So heteronuclear RNA after post transcriptional modification has get converted into mature messenger RNA. So what are the changes you find in a mature RNA? The mature RNA will have a 7-methyl guanylyl cap addition, a poly A tail addition. At the same time, it will have splicing mechanism in which various kinds of introns has been removed and exons has been joined together. So this kind of an RNA is called as a mature messenger RNA. So this is the product of transcription. Now you see what are the requirements for translation. What are the requirements for translation? So the first requirement is obviously your mature messenger RNA, which is the end product of transcription, right? Why you want a mature messenger RNA? It has got the codons. You need these kind of codons for translating it into a specific amino acid, and this amino acid in a specific sequence will form a protein. So the first requirement will be your mature messenger RNA. So the second requirement will be some kind of an adapter molecule. What do you mean by an adapter molecule? See, these codons use a language of DNA and RNA. It is a genetic language. This genetic language has to get translated to a protein language. So you need to have an intermediate adapter for decoding this genetic language to that of the protein language. So this adapter function is being carried out by a RNA called as tRNA. otherwise called as transfer RNA. Okay. So, this transfer RNA act as an adapter molecule. Okay. We will see the properties of transfer RNA now. I will try to draw the diagram of a transfer RNA. So, this will be your 5' end, this will be your 3' end for a transfer RNA. So, this transfer RNA, this is a transfer, this is a RNA molecule and it has undergone extensive number of modifications to appear like this. Okay, this is 5' region, this is 3' region. Okay, so we have got various different kinds of arms here. Okay, so this arm is the anticodon arm. This anticodon arm will go and it will try to find the correct codon. That is the function of this anticodon arm. See, you have a mRNA here